Hello students, welcome back to the online lecture series of Basics of Computer Network. Myself, Assistant Professor Mr. V.R. Vadekar from Matoshi College of Engineering and Research Center, Nasik. We are studying Unit 3, that is Multi-Access Mechanism and Ethernet Standards. Before moving to our today's topics, let's have a quick revision. Students, in last lecture, we seen that what is IEEE? What does IEEE it does? In 1985, the Computer Society of IEEE, they started a project, 802. We have seen the different projects related to LAN technologies as 802.3, 802.4, 802.5. And we have started with Ethernet, that is 802.3 project. In that, we came to know what is the frame structure of Ethernet. How they have divided the data link layer into two sublayers, that is LLC and MAC layer. Then we have seen the addressing, how to recognize unicast, multicast and broadcast address, and how the address it is being transmitted. Today, we are going to see the categories of standard Ethernet and what is switched Ethernet. So let's start with our today's topic. So students, standard Ethernet, it defined several implementations, but only 4 of them it became very popular. This figure, it is going to show you that what are the 4 different implementations were there. 10 base 5, 10 base 2, 10 base T and 10 base 5. Now, in this nomenclature guys, that is a 10 base. Over here, 10 it is going to indicate you the data rate, that is 10 Mbps. And the term base, it means what? It is a baseband digital signal. And this digit over here, it is a 5, 2, because basically they are going to tell you the maximum size of the cable in 100 meters. Suppose 5 it is there. It stands for 500 meter. 2 stand for 185 meter. T, it is nothing but your unshielded twisted pair cable. And F stand for fiber optic cable. Now, as we know these all standards, they are going to use a digital signaling baseband at 10 Mbps rate. So at the sender, the data are converted into a digital signal using what? Manchester scheme. And at the receiver, this received signal is interpreted as Manchester and decoded into data. Because as we know, Manchester encoding, it is a self-synchronous. And it is going to provide a transition at each bit interval. This is the summary of your Ethernet categories, that is 10 base 5, 10 base 2, 10 base 3 and 10 base F. The second column, it is going to tell you the which cable we are going to use. And third column, it is going to tell you the data rate. Fourth column, it is going to tell you the how much, what should be the maximum length of the cable before the repeater it is needed. And it is a maximum number of computers per segment you can join it. So let's start one by one. 10 base 5. The first implementation is called 10 base 5, or it is also called as a thick Ethernet or thick net. Now this name, it derives from the size of the cable, which is roughly the size of that garden hose. You can see from the figure, it is very, very stiff. You couldn't easily bend this, cable with your hands. And it was a first Ethernet, specification to use this bus topology. And these connections, these are made using this tap to this thick coaxial cable. And the maximum length of the coaxial cable, it should not, or it must not exceed 500 meter, as I already told. 5 stand for 500 meter. Otherwise, what would happen? Excessive degradation of the signal, it was going to take place. But due to this connection, it results in a poor connection between your computer and your coaxial cable. The transceiver cable maximum, it should be 50 meter from the station to that tap. And these are the cable end. Next is your 10 base 2. This is a second implementation, which is also called as thin Ethernet or CheaperNet. Now, this 10 base 2, it also uses a bus topology. But the cable is much thinner and more flexible as compared to your 10 base 5. And in this case, the transceiver is normally a part of the network interface card. See the distance, it is very, very near, as like it is a part of this one. And over here, the collision are here occur in this thin coaxial cable. And also, the implementation is more cost effective than your 10 base 5. Because this cable, this coaxial cable is very, very less, expensive than your thick coaxial cable. And this, instead of a tap, we have used a T connections over there, which are also much cheaper as compared to tap. So installation is simpler because this cable is flexible. But however, this length of the cable, it should not exceed 185 meter, which is close to 200 meter, due to high level of attenuation in thin coaxial cable. The distance, it is being reduced, and after that you need to use a repeater over there. Since this distance is very, very small, so there is a good connection between the computer and this coaxial cable. Next is your third implementation called 10 base T, or it is also called as twisted pair Ethernet. 10 base T, it uses a physical star topology. The stations are connected to a hub via this two pair of twisted pair cable. So this two pair of twisted pair cable, it is going to create a two paths, one for sending and other for receiving between your stations and this hub. So whatever any collision, it is going to occur in this hub or switch compared to your 10 base 5 or 10 base 2. So basically, hub, it is going to replace the coaxial cable as far as collision is concerned. And the maximum length of the cable, it is defined as what? 100 meter. And this cable, it is nothing but we are going to use is, it is unshielded twisted pair cable. And last category, last implementation, it is your 10 base F. F stands, start for fiber Ethernet. So although, there are several types of optical fiber 10 Mbps Ethernet, the most common, it is your 10 base F. It uses a star topology to connect your stations to this hub. And you can see in your campus where, that is good for it is a high speed connections. And basically nowadays in buildings or in your areas, they use fiber optic cables. So this is the summary of standard Ethernet implementation. All they are going to use a line coding, that is a Manchester encoding. Now guys, before we are going to discuss the fast Ethernet or gigabit Ethernet, we need to discuss the changes that occurred to the, this 10 Mbps standard Ethernet. And these changes actually opened the road to the evolution of Ethernet to become compatible with higher data rate LANs. And the first step in the Ethernet evolution was the division of a LAN by bridges. It has two effects on Ethernet LAN. First is, it is going to raise the bandwidth, and second, it is going to separate collision domains. So suppose in an unbridged Ethernet network, the total capacity is 10 Mbps, and which is going to share, among all the station with a frame to send. So the station, they are going to share the bandwidth of the network. So if only one station has frames to send, it is going to get the benefit of all that total capacity of 10 Mbps. But if more than one stations are there, here it is a first station and here it is a second station. So the capacity is shared now, the 10 Mbps, it is being shared. So when one's first station, it is going to sending, see at this instant, when first station it is going to send the frame, the second station it is going to be refrain from sending. It is not going to send the frame. Second station it is going to send the frame, and the first station it is, refrains from sending. It is not going to send. It means they are going to send it alternately. And hence, on an average, the bandwidth is what? 5 Mbps, at a rate of 5 Mbps. So in this problem, the bridge, it is going to help over here. So a bridge, it is going to divide the network into two or more networks. You can see on the figure that without bridging, this is a one network, whereas with bridging, it is going to create two different networks. So this 12 station, a network with 12 station, it is divided into two networks with each 6 stations are there. You can see on the screen. Now, each network has a capacity of 10 Mbps. So this 10 Mbps capacity, it is going to be now shared between 6 stations. Basically 7, because bridge is also included over here, but not 12. So after adding this bridge, the bandwidth, it is not going to be shared among 12 stations, but rather it is going to be shared only by this 6 stations only. So instead of 10 by 12 Mbps, each station it is going to get what? 10 by 7 Mbps rate. So this is the advantage of using this bridge over here. Now, if we talk about separating collision domains, this is another advantage of a bridge. It is the separation of this collision domain. See the collision domain in without bridging, and this is with bridging. You can see it over here. This bridge, it has 4 ports. So 4 networks it has been created, 4 domains it has been created. So the collision domain, it becomes much smaller, and the probability of a collision, it is also reduced tremendously. And without bridging, you can see 12 stations are there, which is going to access this medium. So the collision domain, it also gets smaller, and the probability of collision, it reduced in your bridging network. Now, switch Ethernet. The idea of bridge Ethernet, it can be extended to this switch Ethernet. So instead of having four networks, why not having a n networks? Because for bridge Ethernet, there is a limitation on this network. But you can create an n number of stations on a LAN by using switch Ethernets. So you would have a multiple port bridge. So you have over an n port bridge over here. So in this way, this bandwidth is shared between only the switch and this station. And also the collision domain unit is divided into n domains. And next, it is your full duplex switch Ethernet. One of the limitation of your 10 base 5 or 10 base 2 is that communication, it is a half duplex, but 10 base T is always full duplex. So in half duplex, a station can either send or receive, but may not do both at the same time. So the next step in the evolution of the switch Ethernet is what? Is full duplex switch Ethernet. It is going to increase the capacity of each domain from 10 Mbps to 20 Mbps. Each now stations can transmit and receive at the same time. In this, one of the disadvantage of this full duplex switch Ethernet is that there is no need for CSMA-CD. Each station, it is connected to this switch via this two separate links for transmission and from reception. So they are going to send and receive independently without worrying about the collision. And each link, you can see it is a point-to-point. That is dedicated path between station and the switch. So no need for carrier sensing. No need for this collision detection. Hence, the job of your MAC layer, it gets, very much easier. So it's all about, guys, today's lecture. So we have seen about the different categories of standard Ethernet, that is 10 base 5, 10 base 2, 10 base T, and 10 base F. And what are their characteristics? What is the maximum size cable? What is the data rate? What is the line coding that they are going to use? All we have seen. Then after that, we have seen that how to increase the capacity of the network by using bridge. How they are going to increase the capacity as well as how they are going to separate out the collision domain. Then we have seen the changes in that 10 Mbps standard Ethernet, switch Ethernet. Then again, extension to switch Ethernet, we have seen a full duplex Ethernet. So the capacity from 10 Mbps to it has been raised to 20 Mbps. So here, it's all about today's lecture that we have studied. Here it is an assignment that you need to solve. Please note down this assignment. The next module, we are going to discuss about fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, what is IEEE project 802.4 and IEEE project 802.5. Here's my mail ID. So thank you very much students for today's lecture.